All right, this is learning target 6, solving quadratic equations using the quadratic formula. So by now we have factored, we have solved algebraically, meaning we add, subtract, take the square root, and this is just kind of going to be a quick and easy way to find the roots of a quadratic. There are different benefits solving each way. Solving using factoring is beneficial in some ways. Solving using quadratic formula is beneficial in some ways. Solving algebraically is beneficial in some ways. And that's learning target 2, where you're asked to justify the conversions. And so we'll talk about that more in part 2 of LT2. But we're just going to introduce the quadratic formula today. And so it is really only used when you have a quadratic written in general form. Okay, a squared, or a times x squared plus bx plus c, where a is that leading coefficient, b is that number that when we factored was the sum, and c is when we factored was the product of the two opposite of the roots. So when you have this general form, then you can always take a negative b plus or minus, that's where you're going to get your two answers. So there will be two answers because we have x squared. The square root of b squared minus 4ac all over 2a. Okay, so we can get that down. That's the rule that we're going to use to solve this. So in our examples, I'm just going to write that up here for myself. That was negative b plus or minus the square root of b squared minus 4ac all over 2a. And we can literally just plug and chug once we have our equations in general form. So I'm going to transfer this equation into general form by adding 2 to both sides. And then we have negative 4x squared plus 1x, I'm going to write, and then plus 2 equals 0. So here's our general form. We have an a, we have a b, and we have a c. So we literally can just plug and chug here. We're going to take negative b, so negative 1 plus or minus the square root of b squared, so 1 squared minus 4 times a, which is negative 4, times c, which is 2. All of that over 4, or negative 4, excuse me, times 2, so 2a. Right? And if we do some simplifying, that's negative 1 plus or minus 1 squared is 1, negative 4 times negative 4 is positive 16, times 2 is 32, so that's the square root of 33 all over 2 times a negative 4 is a negative 8. All right, and then we have negative 1, and actually, because this is an irrational number, the square root of 33 is an irrational number, this would be the most exact way how to write that, okay? But we can do some approximating with our calculator. So if we have negative 1 plus or minus the square root of 33 is 5.74 approximately, okay, dot, 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 going on forever, all over negative 8. All right, so then our two options would be negative 1 plus 5.74, so that would be 4.74 over 8, negative 8, excuse me, or negative 1 minus 5.74 would be negative 6.74 over negative 8, which the top one here, that will give us negative 0.59, and this one will give us positive 0.84. Okay, so those are our two roots. X equals negative 0.59 and x equals 0.84. So this is a very skinny parabola that hits at negative 0.59 and 0.84. Okay, let's try another one. So here we have a So we plug and chug. We have negative b, which is negative 2, plus or minus the square root of 2 squared minus 4 times 1 times 7, all over 2 times 1. Reducing that, that's negative 2 plus or minus the square root of 2 squared is 4, minus 4 times 1, 4 times 8 or 7 is 28, so 4 minus 28 is going to give us a negative 24 all over 2 times 1, which is 2. Okay, here's what's wrong. We have a negative under our square root symbol. You cannot square root a negative number. It does not exist, okay? So really what's going on here, we can look at this on Wolfram alpha. And so our equation was 1x squared plus 2x, 1x squared. So that was our equation. If we plug it in here, let's get a visual of what's going on here. If we look at this parabola, it does not touch the x-axis. So because it does not cross the x-axis, there are no times in this equation or this parabola where y equals 0. So we have no solution there. All right, we can go back here. Because we have a negative under the square root, that's a dead giveaway. This has no solutions. Because it's a parabola that looks like this. All right, it does not cross the y-axis. Before class, try to solve this equation using the quadratic formula. What do your answers tell you about the graph of the parabola in this equation? So try to maybe sketch the graph for us.